Well, found a little more time again today. So let's take a look at that kind of ground shunt setup. And let's take a look at what we see on the scope when we have different ground shunt options. We'll compare it to normal ground and then we'll look at a few different things. The rheostat in combination with capacitors by themselves, the rheostat by itself, diode, varistor. So let's see what we get. Okay, let's start with the straight ground connection to the center tap of the L2. Right now we'll be just running at 3.2 megahertz, just as a common reference. And the scope right now I have kind of set up so we can see a little bit more of the profile. I'm going to try to do this with one hand. So we still, even with the ground connection, get that kind of trumpet wave profile and that odd charge curve profile. And we see about a mean average of 58 volts on the capacitor. And then again, that's a 20 microfarad capacitor. So let me see here if I can actually go in and measure. Again, sorry, trying to do this with two hands. We'll put our starting point there. And we'll measure the time to the peak, and we get about 1.5 seconds on the straight ground connection. So let's try something else. Let's try now with the rheostat connected. I have it basically straight connected through, and right now it is on the highest resistance, which is 1 kilo ohm. And you can already kind of see the L2 coil is producing almost nothing. Just for posterity, let me see if it changes frequencies in any way. I'm way up here in the 5 megahertz range now. Let's go a little lower, see if other interesting things happen. Nothing quite like what we were seeing before. There's a little something down at 1.7, 1.8. Now let me lower the rheostat. One moment. Okay, we're back up at 3.2 megahertz, and I'm going to lower the resistance of the rheostat. Again, sorry, trying to do this one-handed. Probably about halfway now. And you can see on the lower resistance levels, we're getting back up, and pretty much right there, I'm probably shorted back to ground. So it looks like the rheostat by itself provides kind of a negative effect into the ground shunt connection. Now let's try a 100 nanofarad capacitor. You can already see that the L2 is doing pretty good, but it does not like to come up at that point in time. Let's try adjusting some frequencies. Nothing really special happening anywhere. It looks like the whole reference for L2 is now gone negative. Now let's try with the rheostat back in parallel with the 100 nanofarad capacitor. Again, I have the rheostat all the way up at its highest resistance value. And we're going to short out the capacitor. Still at 3.2 megahertz. And we get back into that kind of trumpet wave profile. And let's again measure with our cursors. So a little bit slower at 5.9 seconds compared to the 1.5 seconds of the straight ground connection, but it's a bit odd that now I have a big resistance in parallel with a capacitor that individually they didn't provide real much value and actually hurt the charging of the capacitor, and then now together it provides pretty much the same charging profile as we had before. Slightly slower, but still there. Okay, now let's try and parallel a 100 picofarad capacitor with the rheostat, again up at the high end, the 1K setting. You can already see the L2 is much lower than it was. Still at the 3.2 megahertz, but it doesn't seem to be able to kind of come back up. I'll adjust the frequency up a little bit. That seems to help. So it seems to kind of prefer a higher frequency. Right now we're at about right there. It's interesting. 4.6 megahertz. Let's see what happens when I short out the capacitor. I'll go a little lower, 4.3. Shorted. So similar effect, but not as strong as what we see when we use the larger capacitance. Okay, now let's try a 1 microfarad capacitor in parallel with the rheostat, again still at the highest setting, 1K. And we can see here that the L2 is actually running at a good level, and we'll attempt to short it out. And let's measure there. And measure the high end. Takes a little longer. So up here, again, we're still at 3.2 megahertz. But it was a little bit slower on that one. So there might be some sweet spot with capacitance that we can try to play around with. Okay, now we have a 10 nanofarad capacitor in parallel with the rheostat, still at the highest level. Still at 3.2 megahertz. Let's see. Time. And let's measure. So it's just slightly slower than the straight ground connection, but not really negatively impacting the timing very much, 1.56 seconds. So one thing to keep in mind with the rheostat is that it's not just a resistor, but it's also an inductor. The way they wind the resistive wire basically creates a large inductor. When it's at the full 1K ohm setting, I've measured it, I think, at about 2 millihenries. So I've reduced it by half, so we should get about 500 ohms right now. And let's see what happens to the settings. And this is still with the 10 nanofarad capacitor. One more time for timing. Again, about 1.56, maybe slightly better. If I get a little more accurate with the values, about 1.54 seconds. So a slightly lower resistance may improve it, but it seems negligible at the moment. Okay, so I've removed the rheostat and capacitor, and I've now placed a diode as the ground shunt. And let's see what that does for us. Already you can kind of see the L2 is not running at a expected level. It does jump up very quickly, but the final voltage is much, much lower. And this diode only has a half a volt drop. We're looking at 21 volts versus 50 some volts previously. Now it does jump up very, very quickly. And this is still at the 3.2 megahertz. Now I did notice with the diode, if I go up in frequency, now I'm at 4.1 megahertz, it does seem to actually get back to that trumpet wave charging profile. And I think if I go even a little bit higher to 4.6, Just get me back up again, but very, very slow. Actually, I'm at 4.5 right now, but then it kind of hits this ramp and then really starts going. So let's try 4.4. There's 4.4 again. So interesting effects with the diode, and that it actually pushed the frequency that we're operating at up by an entire megahertz. Okay, now let's try with a small varistor placed as the ground shunt. This varistor is a 30 volt clamping voltage. You can already see L2 is looking pretty good, but as it short out, ramps up pretty quickly, but it has about 10 volts lower than what we saw with the straight ground connection or the varistor capacitor connection. I don't want to measure this because it'll be not quite the same measurement. Okay, now let's try a straight up resistor in parallel with the capacitor. This is a 10 ohm non-inductive resistor and still with the 10 nanofarad capacitor. It's a nice profile. I think a pretty high voltage. It looks a little slow. Let's see there. And as well, let's measure the bottom end. So, I mean, right around everything else. So, a small resistor in combination again with the capacitor still seems to do the job. Now let's try that same resistor, but without the capacitor. You can already tell it's very slow comparatively. Probably not going to move. Let's see if I can capture a measurement. 2.26 seconds. So it seems that resistance by itself is negative, but in combination with the capacitor, it is almost acting, like I stated, as a diode. Slightly negative impact versus the straight ground connection, but is still able to pass through the ground to the system without impeding the system negatively. And of course I should actually test now with no ground connection. So there is nothing connected to the ground at this point in time, at least for the center tap of the L2. And kind of as we would expect, we see a flat line. Even if I change frequencies a bit, really nothing is happening much on that capacitor because there's really no charge flowing as far as I can tell. So thanks for viewing. Hope you found that interesting. I did find it interesting that the kind of combination of resistance and capacitance provides some path for the charge to flow kind of straight through that ground shunt and is almost as similar as having a ground connection. But we were still able to see the trumpet wave effect at this frequency. With a straight ground connection, I can't say that that's going to be completely helpful all the way through higher frequencies, or as maybe we tune up the system. So, thanks for watching. Appreciate any comments, and we'll see you next time.